Oh, well, sorry about that interruption, but you most probably needed a break anyway. And I most probably needed to just carry on from where I was. So we were looking at next and previous. We just looked at pause and resume. So we'll look at next and previous. So for the next track command, we increment the current track number, resetting to 0 if it's the end of the playlist. At the end, play the new track. Okay. So this time the code really is we read the persistent attributes, and we get the track number. We increment the track number, modulate it, and save it away. We also set the next streaming queued false. We'll come back to that in a bit. And then quite simply all we do is we just normally do our play directive, replace all, we get our audio key somewhere up here. Get our pre-signed URL and our audio URL, and we run the play directive from the beginning with the offset to 0. So that's okay, that's easy enough. That's the add, that's the next. For the previous, I just subtract 1 to it, read the track number again, subtract 1 off to it, but if it's just less than 0, I just set it to 0. I don't go loop round the tracks, although you could put some code in there for looping if you want to, which is also in the Alexa Amazon example. Okay, so we save the next track away, and we set next streaming queue to false. And we do the same all over again. We get a audio URL from a pre-signed URL, and we set our directive with the offset in milliseconds to 0. Okay, we're getting quite a lot of duplicate code here, but I'm deliberately doing that so that each one's sort of self-contained. If you want that, you can look at the Alexa GitHub example, and that's here. So, we might also have a problem when a user says start over again. So we just want to start the track from the beginning with the same track from the beginning again. We don't need to do much here. Again, read the persistent attributes, read the current track number, set the offset in milliseconds back to 0, and set a play directive with the current track and a new pre-signed URL, and the offset in milliseconds to 0. Okay, and then we'd save the persistent attributes away, and obviously we save them in the interceptor. Okay. Alexa also has a playback nearly finished handler. What this does is this adds a new stream to the queue so that you don't have to wait when you've got to the end of a track. You don't have to go down and reload everything. It can start playing automatically. The problem that I have is that as I use the track number to get the next track, things can get out of order. When the next track is automatically played, I have a record of the previous track. I don't keep a record of the automatically played. If I update it when I update the playback nearly finished handler, then of course, if you say start over, it would start over the wrong track. So to get around this, I keep a record if the played track is from the enqueued or not, and I check for this in the playback finished. So normally we'll see a play behavior replace all, but somewhere we'll see down here we've got an enqueued. Okay, so what will happen is we'll normally be playing a track from a replace all. If it comes to the playback finished, it will run the enqueued, and from the beginning and from whatever track that we've told it to play from, But in this case, we'll set the next streaming queued to true, so we know that it's playing from the end queued. So I'll just talk you through that. What we've got here, we've got the nearly finished handler. Obviously, if the track's nearly finished, I want to go and get the next track. So I do what I did before, get the next track modulo it, save that away. Sorry, I get the token. And this is where Alexa needs to know about this expected token. What it does is it does a compare. There's a bit here about playlist progression, which Alexa describe if they have a similar problem. If it's automatically keyed up to play the next track, and then the user says something, the Alexa device can get screwed. So the way Alexa get around it is they look at this expected previous token, and if it's different, it knows whether it's come from a play or whether it's come from the nearly finished. So I this time have to save the previous token, and we'll see that here. So we don't set that to none this time, we set that to the previous token, which is basically the track that we are about to, or we will play when it automatically finishes. The rest of this is all the same stuff we've done before. Milliseconds to 0, state the token, audio URL, these are all for the next track, and set the next streaming queue to true, as opposed to next streaming queued, if we've got an example here, to false, which I do everywhere else. Okay, this time, instead of sending a replace all, we enqueue the track, and I'll let you look more about that in the documentations about all this. But this one here is quite an interesting problem they've got and how they get around it. Playlist progression. Okay, so I've got to come in here. So the next will be new URL, but the track number's wrong, so that's how we keep a track of it. Okay, now we need to edit playback finished. Also, when we get a track finishes normally, we get a playback finished. So in this case, we're going to get the persistent attributes. If the playback settings next streaming queued is true, we know the track ended naturally and the enqueued is playing, so the track number is wrong. So if it's true, we set it to false, we get the track number, we increment the track number because we know the next track's playing. If you're doing this from a playlist, you'll have to look it up on your playlist, and we save it away. And that's all we need to do in the playback finished. So I think that's it. We can look at all this code here. So remember, what you've got to do is you have to upload your code to S3, remember your URLs, create this trackinfo.py, modify this requirement.txt, and change the functions in your Lambda function. So we looked at the audio play by adding a resume function to it. The audio stop doesn't do anything, it just sends a stop directive. The playback started doesn't do anything, that just starts. The playback finish, we'll look at it in a minute. This playback stopped basically records the offset in milliseconds, which we pick up when we start again. The playback finish, if you remember now, we look to see whether the next streaming queued is true, and if so, set it to false and get the next track. Playback stopped. Playback nearly finished is this bit about recording the next track and sending an enqueued directive with the next track. Playback failed, exception encountered, Then next, all we do is we get the next track, save that away, and start sending a play directive to play the next track. You can say that at any time. And the previous, we do the same. We go in, subtract 1 from the track number, limit it at 0, save the track number, get a new pre-signed URL, and send off a new play directive. Start over just starts the current track from 0, offset milliseconds from 0. And that's everything, except I did add these interceptors as well, which you don't necessarily need, but they're there. So the code's all available at this GitHub, or my GitHub there. Here's the part 2 code. There's the Lambda function. Oh, I could add the request, I suppose, .text, sorry, the requirements.text, but that's easy enough. And this document here is also here. So there's a YouTube video, you can watch that. I'm not going to play you that, showing basically how I test it, and I've got a little bit of a test regime at the top up here. So the only thing really left then is a few other things to try. I mean, you could say play track 3, go to a specific track, or you could request a specific genre or artist. You could loop it, add a playlist, or add touch control for devices with the screen if you want to. Okay, well, enjoy that. Video of it workings at this YouTube site, and all the files you need are here. But you've most probably got that. Anyway, okay, so I hope that you're helpful, and wait for the next exciting video.